Hello. So thank you very much for joining our talk so late in the afternoon. My name is Maxim, and I'm here with Tom, and we both work for the company which is called Unbabel. We are based in Lisbon. What we do, we try to build a universal translation operator. So, and the vision of the company, you see it's the slides. So we are trying to build universal understanding. So those of you who remember internet in the late 90s, I recall that there was not much content available in languages other than English. Right. So these days it's different, of course. These days English is the main language, but comprises no more than 30% of content in the internet. So now we're talking about the rise of Chinese, Japanese, Portuguese, Spanish, and many other languages which you can find on the internet. And of course, it's both a problem. How to translate between all the languages, right? So, actually, if I mean, businesses, for example, or individuals start looking for a solution for this problem, they have two extremes. One extreme is machine translation. Well, we know all Microsoft Translator, we know Google Translate, we know that it's affordable, we know that it's fast, it's basically almost instant. But we also know that in many cases, it's in some cases it might have flaws, right? Translation flaws. Another extreme is professional translation. Professional translation is different. So we know that it's expensive. We have to pay people for translations. It's slow as well because humans are not machines, so they need time to work on translation. And there's also one more problem, because if we want to translate the content, which is translate internet, which is produced in the internet, even on the daily basis, we won't be able to do it because all translators together in the world won't be able to translate more than 1% of this content. So, and when we're talking about translation these days in the internet, we are not talking about traditional web pages anymore. It's more than that. So we, I don't know, those of you who spoke with the customer support departments of any company these days most probably used different channel than before. I mean, it's not really like submitting tickets and waiting for an agent to reply or calling them anymore. It's chat, right? I mean, in many cases, you just go to the chat and start speaking with the agent or with the bot or whoever. So this content can be translated, and that's one of our main focuses as well. So we're also talking about video. I mean, descriptions, subtitles, these things. They also can and should be translated. We're talking about different types of APIs, about product reviews, about product descriptions, and many more. So how to deal with all these types of content? Our answer to this question is basically a language operational system. So it consists of two parts. The core part of it is called language engine. So here we're talking about artificial intelligence working side by side with humans. We'll get to it a little bit later. And to make sure that actually our language engines are connected to the customer applications, to basically our users, we build another layer, a layer of APIs. And here we're talking about Chat API, we're talking about Messaging API, about Core API, and we ensure that our engines are connected to Salesforce, to Zendesk, to Microsoft Dynamics, and to many more applications. So let me tell you, the professional translation industry is a pretty old one, and it's not different from many others, right? So it's all about balancing three things. It's cost, speed, and quality. But apparently, it's easy to optimize too, right? Just pick two of them, speed and cost, for example. It's quite easy to build a product. We should optimize them. But if you want to focus on all three, it's becoming a tricky one. So at Unbabel, we have several pillars to address this problem. So one of them, and the biggest one, is artificial intelligence, and that's what we're talking about today. So it's not just machine translation, right? Machine translation engine is like a small part of a solution that we have to build. So think, for example, about the quality of the source text. So when you get text to machine translate, you have to be sure that your engine has seen this text or similar text, and it can produce a translation which is better than random set of words. Another problem is how to project tags from source to target, right? So if you have like any HTML or XML text in the source, you need to make sure that after translation you put them in the right place, and many other problems as well. So quality estimation. Quality estimation is probably something that not many of you know about, and that's what Thomas will go into detail in the second part of the talk. But to give you an overview, it's a tool which allows to tell you how good or how bad your translation is without looking at the reference translation. So we have a component for that too. Another one is Smart Check. Smart Check is our know-how technology, which helps post editors, so basically humans who are in the loop, to do their job efficiently. So it's a spell checker. It's a tool which allows to select words in the best possible way. It helps to focus on punctuation and things like that. And of course, we have like an automatic editor evaluation tool. We, sitting here in Lisbon, we're not positioned very well to tell our Chinese post editors, for example, how well they're doing their job, right? So we want to automate this process on the technology on the core process side. We also have a pool of editors, so people who do the final touch to translation after looking at the machine translation output. And we have some other technologies to balance the three things. So, but we're talking about AI here, right? So the two main components of our system is neural machine translation and quality estimation, as I said. So those of you who have used Microsoft Translator or Google Translate or any other generic machine translation solutions over the course of the last month or maybe years might have noticed how much it has improved. And it's mostly because of the deep learning revolution. You probably heard about it. So now actually machine translation engines are built on a very different principle than 2-3 years ago, and it ensures a better quality. Another component is quality estimation. It's a very similar story, because even 5 years ago, even maybe 2 years ago, it was a pretty small technology which not many people believed in, and maybe outside academia. And these days it's becoming a thing. It's becoming a key component of business solutions, multilingual business solutions. So let me show you two scenarios. So two versions of our pipeline, right? In the first one, we have service level agreement. Let's say 20 minutes. In 20 minutes, our customers expect us to submit. So how do we do it? So first of all, we take the text from our customers, we send it to the machine translation engine, and afterwards we show the output of machine translation engine to the quality estimation module. Right, and this tool tries to distinguish good translations from bad translation. If translation is good enough, then we send it directly to the customer. If it's bad, then we send it to humans, and humans send it back to the after they do their job, they send it back to the quality estimation module, and this process repeats until we get decent quality translation. So, but it's not the end of the story, because we also want to make sure that our engines improve over time. That's why we send translations back to the training module, and we make sure that our system takes these new chunks of data into account, we train them, and it improves over time. Another scenario, which we call offline, we basically don't have to send of machine translation to, right? Well, and the expectation customers, they speed, and then we are sending translation output. But it's not because we also want to involve users, because we want to ensure of our system improve. So that's why after sending the customers, all the data selector module. So selector does, it tries to understand whether the data that's created for this in moment is different from what the system, right? And if it is similar, if one word is different, some numbers are different, and all the rest, we don't translate this data with human, and we believe that our system, we send it to the module, involve humans into the process, sure that this data the translation loop. We see machine translation are two main components of And let's talk about it in detail.
Hi. Yes. So we use quality estimation to find the answers to questions that we have. Is our translation good enough to send to our client, or does it need to be post-edited? And if yes, which parts of the translation do we need to post-edit? So let's take an example. And we have an original document that here is in Spanish, and it's machine translation that is in English. Now we can evaluate that at several levels. We can give a score to the document between 0 and 1, 0 being good, 1 being bad. We can do that at sentence level. Like for each sentence in the document, we can give a score, same, between 0 and 1. Or we can go even deeper and assign to each word in the document a probability of being good and bad. So we get tags that are okay and bad. Bad meaning that we need to post-edit the words. And to answer our two questions at Unbabel, we only need word level and sentence level quality estimation. Sentence level to estimate if we need to send that to post-edition, and word level to guide the editor towards the mistake that he needs to edit. So let's see how we can get the data to train a machine learning system. So we have a machine translation output that would be, I really like machine learning, and a reference output that we would like the machine translation to achieve, which would be here, I love machine learning, with an exclamation mark at the end. And so for sentence level, we want a score. So we could count the number of operations we need to go from the machine translation to the reference. So here, for instance, we would like to substitute the word like for the word love, delete the word really, and insert an exclamation point at the end. And that gives us 3 operations. So we have an edit distance of 3 that we could normalize by the number of words in the machine translation to get a number between 0 and 1, and to make sure we don't penalize very long sentences. And you can do it live if you want. Like the code is very simple. There is an existing package already that you can load in Python. You just have to specify your reference and your machine translated sentence. You can evaluate that, and we found that the edit distance is indeed 3 words in this example. And at what level, it's actually extremely similar. If we take the same example, now instead of computing the number of operations we need, we just need to keep track of which words we edited. And here we edited really unlike that we replaced and deleted. And the rest are okay. And if you look at this example, you might notice a fundamental limitation to this approach is that we cannot tag something that does not exist. Like if we don't have an exclamation mark, how can we tell our system that we have something missing? Fortunately for us, this is something that happens very rarely in a machine translation output, because we can enforce the system to pay attention to every word in the input. So if there is an exclamation mark in the input, that will be in the output. And second, because well, our research team is working on that, and we have experimental solutions already to deal with that. I won't go into details of how it works, but we can make it working. And same, here is an example of what we want to show to our post editors. So we compute a series of OK and bad tags corresponding to the words in the input sentence, and we want to highlight to the post editor where do we think the mistake is. So okay, so now we have the data, we want to train a system. Which machine learning system can we train? And we're using a state-of-the-art neural network architecture called the predictor estimator, which is state-of-the-art on this task of quality estimation. So it looks like that. And it looks very scary, especially if you're not into AI. That will explain the intuition behind, and you'll see that it's actually extremely the big picture of it. Let's look at the left part of it, the predictor. And to understand what's happening, I want you to do a very simple exercise. I'm going to give you a source sentence in English. The dogs are barking in the garden. And I'm going to give you the machine translation in Portuguese. But I removed one word. And the exercise is just to predict which word it is. So for us and me as human, like this is a task that is extremely easy. Like you might have figured it out already. But I want you to focus on your mental process to draw your conclusion. If I do mine, that looks a bit like this. The first step, I get a mental representation of the source sentence. So I don't need to know exactly which words are in which order. I just need to know that the source sentence is talking about dogs, they're in the garden, and they're barking. Then I'm going to look at the left context of the missing word. Here's just the word ush, but I can get a lot of information from it already. because I can know that following will be a noun or an adjective, and it will be in a plural form. And finally, I look at the right context. I see a verb, I see the garden and stuff, so I can know that we're talking about a noun, that it's in plural form, and it's something that barks and something that is in a garden. And of course, the missing word here was dogs. And that's exactly what this big thing is doing. If you look at it, we pay attention to the original sentence, we do a bit of machine learning magic, and we get what we call a source context vector, which is just our mental representation of this source sentence. And we do exactly the same for the segment preceding the word, which is the left context, and the segment succeeding the word, which is the right context. And we combine them together, and we get a final context representation in your head, the representation of the word dog. And the predictor is going to do that for every word in our machine translation. The same process for every word. And we're going to feed that in the estimator. The estimator is just the list of the mental representation that the model made for every word in the machine translation. We feed that in a very simple neural network model, and we get our tags, and we get our sentence level quality estimate. So let's see that in action on simple examples. So let's take a source sentence. This is a simple sentence, and a machine translation sentence. C'est une phrase simple, which is the correct translation in French. Now at Unbabel, we wanted to make QE very seamless for everyone to use. Even if you're not in AI, even if you're not a developer, we wanted to make very, very easy to try to add that in your project to evaluate different models we could have in production. It's a matter of 5 lines of code. The first one is just importing our internal package. It's called Kiwi because it looks like QE, so it's fun. We load the model that we've trained previously in memory. We define a source sentence and our translated sentence that we want to evaluate, and we just ask the prediction for that. And what we're going to get is a simple object that looks like this. We're going to have a tags field which corresponds to the probability of each word in the machine translation of being bad. So this is the first one is the probability of C to be bad in this example, etc., etc. And the sentence scores is just our sentence level estimate. Here we can see that it's very, very low, close to 0. So that means the model is very confident that there is no mistake in this translation. If we visualize these probabilities, we can indeed see they're all extremely low for every word. And so the model is quite confident that the machine translation is correct, and we can directly send that to our customers without sending that to a human. Let's take another example. This is a simple sentence with a little mistake. And now the French translation, c'est une phrase compliquée avec une petite erreur. Here I introduced deliberately an error, compliqué instead of simple, which means complicated in French. And let's look at what the model says. Okay, so now the model is extremely confident that there is a mistake at the word compliqué. See, the probability of being bad is very, very close to 1. And the sentence score now is now at 0.3, which means like a way higher probability of this sentence to contain a mistake somewhere. And so we can highlight the word compliqué, send that to our post editor and say, we think that there is a mistake, and we think that it is exactly here. Now I would like you to notice an interesting phenomenon that is happening, is that phrase and avec, which are the surrounding of the word compliqué, have also a higher probability of being bad. They're not bad because their probability is lower than 0.5, but still they're quite high. And it makes complete sense if you think about how language works. It's a sequential, the language works like a sequence. And so if you have a word with a mistake, like the likelihood of its surroundings containing mistakes as well is way higher. And this is a phenomenon we want to capture with our quality estimation model. Let's see a last example. Same, we take the first example in English. This is a simple sentence, but this time the machine translation system made a big mistake by adding a lot of words that are useless. So that means c'est une phrase simple qui ajoute beaucoup de moniteur, which means in English, this is a simple sentence that adds a lot of useless words. And this is something that is well known in the neural machine translation field. It's called a machine translation hallucination. And it means exactly what it sounds like. Like the model is just hallucinating and inventing words that do not exist in the source sentence. Unfortunately for us, this is something that our quality estimation system is well trained to detect. And again, send that to our post editor and say, okay, we think that there are a lot of do not correspond to the input. And here, like we have a lot of words with mistakes, and the sentence level estimate gets very high, 0.6. Yeah, that's basically it, quality estimation in practice. Now we need to talk about training. We talked a lot about them to predict the quality, but we need to train this system. And the main drawback about using a complex neural architecture like I showed you is that it's painfully long to train. We're talking about 3 to 10 days to train a single predictor on dedicated GPUs. It requires millions of parallel examples that we need to get from somewhere. So we get our post-edit data, of course, but we need also public data that we can find online. And there are a lot of parameters to tweak in the predictor. This is an example of a configuration file for the predictor model. And each line of this file is a parameter you could tweak to get better or worse performance in your predictor model. So you don't want to train only one. You want to train several predictors with different combinations of those parameters so you can get the best performance. Of course, you can try every combination possible because it grows exponentially and it will be completely intractable, but you want to try to train between 5 and maybe 20, let's say. So that's a lot. And we want to support many different language pairs. We want to actually support 15 different languages with quality estimation. So you can multiply the 15 languages by the number of times you're going to train a predictor, the number of days you're going to train, and you get a very big nightmare. And if you don't have a good tooling around that, since you have several people working on that, you will be completely lost in the number of experiments you've run. Unfortunately for us, there is this thing called MLflow, which is an open source software and solves all our problems. So if we look at the bottom part of this image, each responds to a machine learning experiment. And you can find the source code of the experiment, the exact commit, and the list of the parameters you've used for this experiment, and the key metrics, the performance metric of your model. And so you can very easily search for models that satisfy certain conditions, like on your performance metrics, for instance, or the parameters you trained. And that allows us to have like 4 different people training a quality estimation model, and we can track all the experimentations, even if myself, I didn't train this guy, let's say. And I can still find that, okay, maybe this is the one I need to push in production. And yeah, that's basically it about quality estimation in practice. Of course, we could talk about that for an hour. I had to go very fast because of time limitation. If you have any question, please feel free to ask. Thank you.